So yeah, we're here to talk about Sherman. So my name is Mike Wuetherick. I'm the head of technology for an innovation group at Unity. We're focused on the media and entertainment space. And Sherman is a project that was completed by my team shortly after we finished the Baymax Dreams project last year. It was the same core team. Some key stats. This is sort of a general overview. I don't know if I'll get through it all. I'm going to try to go through quickly so that I can get to the guts of it. But how many people have seen Sherman? Okay, do we need to watch it? All right. Oh, wait, go back. Play. Oh, come on, videos. It says it's playing, but it's not. All right, I'll do this. Videos. Let's try this one. So Sherman, so the initial motivation for this was, the first was we had the team from Baymax already on staff, and we wanted to sort of see what what we were able to do with them. Obviously, the Baymax project it's Disney's IP. We wanted to have a bit more of a sandbox that we could play with and share more with the community. So. The core animator on it is Brian Larson. He worked on a ton of movies at Blue Sky. Most famously, he animated Scrat for Ice Age. He's an amazing physical character animator, and it was a joy to work with him. He can do magic with characters. Obviously, the core technology we used is the standard Unity tech stack. Timeline, Cinemachine. Alembic is sort of the first new element that we added here that we hadn't really worked with before, or recently. The HD render pipeline, the VFX graph, and so on. We went from concept to final frames in 18.4. There was no modification outside. All of the frames were rendered straight out of Unity. And then obviously we had this initial fur implementation that we're trying to target offline render quality. So it's not the first time people have tried to do fur in Unity. The most, I think, the earliest one that I'm aware of is the Mars Animation Planet project with Unity Japan. It's a very similar implementation. We actually started on sort of a similar project that had continued internally a few times. There'd been work at a couple hack weeks, building on sort of that. For blocking, are these going to play? Why do none of my videos play? I'm going to try this without presenter view. Sometimes that works. There we go. So this was actually the animatic that Brian put together in a matter of a day or so, just kind of roughing out the ideas of the story. This was actually all done in Maya. We loaded the whole scene in, kind of dropped the animation in, and he just quickly iterated on it. And then Mark Droste, our director, went through and added sort of the quick camera pass. We initially shot it really wide just to give Brian some space to work, so that we could sort of then iterate on cameras. So look dev, we were very inspired by sort of shorts like these, DreamWorks' Bilby, their new gorgeous ray trace renderer. We set a pretty high target for ourselves, just because we're gluttons for punishment. But the real benefit is that HDRP is gorgeous, and you can get some really fantastic results out of it. We had a single modeler on the project. He created all the assets, except for some of the trees in the background that are from the Book of the Dead, actually. We stylized them, gave them a bit more color to sort of fit the look, but almost everything in here is actually the default HD lit shader, most interestingly. So you can, like everything from the gnome to the sprinkler, the dog bowl, you can actually really get a lot of interesting results with just the built-in lit shader. And then there was a couple of custom shader graph things. The big thing in all of the projects that we work on is we're optimizing for quality, not performance. So when you talk to people in the VFX animation world, when they're using real time, they aren't looking for the 60 frames a second that you are in a console game. We're looking for interactive frame rates. I want to be able to work efficiently. So the project ended up being quite heavy. That's kind of why I don't want to do live demos, because it doesn't show the best in person. But we are at that point where we're cranking everything to 11. Along the way, we built some detail systems to turn down the detail on the fur, to be able to turn down some of the shadow, like configuring HDRP on the fly. When we're doing final renders, we've got, the HDRP settings panel has how much memory your shadows are taking, how much your reflections are taking, all these things. And we're cranking them all to about as high as they can go, which doesn't give you the best performance, but it looks pretty. So when we're doing renders, that's what we do. We kind of just crank everything to 11, and it gives us some gorgeous output. So it's figuring out what that balance is of the iteration while you're working to sort of your final. We did a lot of, almost everything was done in Substance, so things like the gnome were Substance Painter. And then we did do some custom shader graph materials for the hose. There was a whole bunch of these properties that you wanted to get the proper, as it stretches and sort of expands, being able to configure these. The nice thing about this is once they're exposed on in shader graph, then you can actually animate them on timeline as well. So you can actually sort of interact with these things live. For camera layout, obviously we're big fans of Cinemachine. Adam Myhill's on our team, so we don't have a choice. No, just kidding. It's super powerful. It completely changes how you work with cameras, and allows you to have things in your scene that the cameras are aware of. So it allows you to iterate on where objects are moving, how quick things are moving around, and the camera framing just works. So you can keep playing around with ideas, really experiment during that ideation phase. It completely changes how you work. Now, the biggest thing is the animators are working in Maya, so you need to be able to get cameras back out to Maya so they can animate to that final frame. And that's where things like the FBX exporter and some of the workflows that we're working on there. That part's still not perfect, but it's a hot topic, and we're working on expanding and refining that. So again, camera layout, you can see the Cinemachine clips, these red clips in the middle here. And then below is actually the animation for each of the clips. So even if you're using Cinemachine and its procedural targeting, you can actually go in and hand key things, enhance things, do some refinement. And you can see here almost every one of the Cinemachine clips actually has an animation element to it as well. So whether that's adjusting focus or framing or whatever Mark wanted to animate as he was going through, you can actually refine the procedural shots that Cinemachine is giving you afterwards with animations. So again, we wanted to use Alembic for our animation. During Baymax, we used FBX, and there was a lot of limitations at the time in some of our skin mesh renders. You had like skin weighting limitations and some of the scale compensation fun that goes along with it. Luckily, the skin weighting one has gone away in 2019, which is fantastic. It makes our riggers very happy. And squash and stretch in particular, where you want to just really just abuse the characters during the animation process. For the Baymax project, again, we kind of did a flat rig hierarchy. So you had your IK controls to manipulate Baymax, and then when we export, we had literally a top tier bag of bones rig for the FK export. It allowed us to do things like squash and stretch, but it kind of made it the previs artist, Mark, made his life a bit of a pain having to figure out how to keyframe animate things or adjust things in the editor. If you've ever tried to do FK animation, it's like that, except even worse. The nice thing is Alembic is an option now. It's a fully supported feature as of 2019-1, and actually is nice because it's a what you see is what you get format. So Alembic is not perfect. It's a pretty big, heavy files format. It's literally doing a snapshot of all the vertices for every frame, so your file sizes end up being large. So you can see here on Sherman, it's a 2-minute short, and the character animation just by itself is 7 of the 12 gigs for the total project size. So the animations are pretty large. Some of them, yeah. And Alembic is streamed from disk as well, so that is its own challenge. You need really fast SSDs. You need, you actually have, it's almost like video I/O, where you can only stream a 8K video from your hard drive fast enough if you've got a fast enough hard drive. Similar challenges. Probably the bigger one though was that Alembic it's a vertex cache, so it's the object's at 000, but it appears over here in space because it's animated. Now, if you want to do things like attach lights to it, or reflection probes, or attach cameras to it, it doesn't actually exist in where Unity thinks it is. So that was sort of a challenge. There is actually the ability to export the actual rig as points as well when you're doing the export from Maya. But you have to be careful that you don't get like a 50 billion, like you're exporting your entire IK rig with the 30 million nested game objects. We did that during the Baymax project and broke the editor, so don't do that. You can really kind of compensate for the attaching with exporting all your rigs. The other big challenge with Alembic is material management. Alembic doesn't really give you the proper information in the file format about your materials. So one of the things that we did is we wrote some tools for sort of batch remapping materials. They're available in this Film TV Toolbox package on the package manager. It allows you to sort of select objects, and then sort of it gives you all the materials, and allows you to batch remap them. Alembic, again, is like one export for every shot in the scene. So we would have 20 different raccoon Alembics in the scene. And every time we wanted to publish a new one, you'd have to update all of the different. So this batch management of materials kind of solved a lot of that problem. Obviously, the future of a lot of this stuff we feel is USD. Unity is really investing in this workflow and the opportunity or possibilities that USD gives you. The USD package on Package Manager actually supports Alembic as well. So I think, for future projects, I actually foresee that USD is going to be the way that we end up working more. For lighting, lighting is essentially a combination of the traditional things that you're doing. The biggest difference being that we only baked the indirect for the GI. Now, the nice thing here is it gives you the sort of that nice ambient lighting, but effectively everything is, once you've done that and you've baked your probes and your GI, then essentially all the lights are real time. So it's not like baked light maps that are now static. you essentially have the lighting information in the scene that allows you to have per shot lights or per shot sun angles and so on, which you can see in a few of these things. We use both types of reflections, sort of the spherical and planar. And then for lighting again, once everything's baked, you can actually manipulate them. I don't know if you can tell in here, but JP actually sets up a pivot where he wants the light to rotate around, and he sets up a prefab with the light so he can actually really easily rotate it around the object. Just one of the tricks that he does for aligning lights really quickly. This is just a quick video of him. So in the lighting prefabs here, you can see he has sort of specific types of lights that he wants to create. And we use nested prefabs, obviously the workflow there, to quickly iterate and change. And this one, he's going from like a day to a night just by editing one prefab. Per shot lighting, we use activation tracks. And you can see in the top here, he's got a prefab per essentially shot. And he's changing essentially for the camera to get the right types of light. He then sets up the scene, configures how the cascade shadow map, different distances, turns on whatever other things. You can see he's drastically changing the time of day for different camera angles. Again, when you're working in linear animation, it's all about what's in the camera. So you can do all kinds of weird abusing of the lights like this. Obviously, fur is an interesting topic. First, let's talk about the VFX graph, though. This was our first experiment with VFX graph. Vlad Nakov was sort of the wizard that we borrowed to work on all the VFX. The VFX graph is obviously a node-based visual effects tool. It's available, actually, it's coming out of preview in 19.3. It's amazing. It allows you to do all kinds of crazy stuff. Now, the initial, this was actually one of the very first experiments that he did, was to try and have sort of one solution for all, like one water for all the use cases. It didn't work out that way. As you start refining per shot, you end up almost having custom effects per shot. This is just a quick GIF of sort of what it looks like with the VFX graph. So everything from the little leaves falling down, you can see there's a custom timeline track that activates the effects, and then you can refine and sort of interact with them and actually edit the graphs live while you're previewing it in timeline, which is really handy. All of things like the dirt clumps, these are all, again, their own custom graphs, and you can tweak them, enhance them, manipulate them on the fly. It's really, really powerful. For fur, our initial thought was, well, we're not going to do fur because that's scary. So this was actually the original style we were going to go for, is sort of this stylized sort of approach. But we have a problem of being able to say no to things. So then this was actually the very, very first implementation. It was just brute force hull approach. We kind of thought, oh, hey, we might actually have something here. You can see there's the tail's kind of weird. We had to figure out the authoring and so on. So what we did for the fur was, the first step was actually modeling the fur. So the artist actually created the 3D assets and brute force modeled the fur. Our graphics engineer created a SDF baker to convert that patch into essentially this magic thing that he loves, that the artists can groom. We have a combination of per normal strands and then also a screen space, which kind of allows us to blend between the different depths, because we lost some of the fidelity with just one or the other. So we actually can kind of tune and blend between the two approaches. All of the groom maps themselves were painted in Mari. It's got the weirdest interface ever, but it's super powerful. And you can see how he was able to actually really refine how the fur interacts. And some of the challenges where you can see on the cheeks here, like what happens here, like how do you author for that? So it was really critical that we gave the artist the ability to refine and sort of really tune the groom maps for the. We didn't want to just a universal fluffiness. That's not how things work. So we had an experimental implementation of fur in 18.4. This was all based on 18.4. The shading, the actual rendering of it, uses the HD lit, the hair master node that's available. So what we were focused on was more the geometry generation, and then how does it actually interact and author in the scene. But the actual shading just uses the normal Kajia K that HDRP provides. We are currently in the process of updating all of this tech to the 19x tech stream. Like right now 19.3 LTS, kind of aiming for the LTS. And we're collaborating with the graphics R&D team on what a proper fur implementation would look like to roll out for other platforms and more performant runtime uses. Obviously, the ideal scenario would that we can actually groom the hair or groom the fur in the editor. So that's something that we're investigating as well. Some other tools that or things that we use. So we use the recorder package, had timeline integration. You can see there's a timeline track here for the recorder. It lets you configure the output. We output our finals at 4K PNG, and I had a render farm of 3 machines sitting on my desk that I set up basically remote desktop in, so the team could log in and render. So we basically did a render every night. One of the other interesting things that we built initially for Baymax, and we're kind of continuing to iterate on, is our sort of what we just call initially was filmic motion blur. It's kind of evolved into more of a super sampling accumulation system. So we actually render the whole thing at 960 frames a second, but we're accumulating sort of 40 samples, and then sort of that becomes the super filmic motion blur for the final output. The downside to this initial approach was that it was pretty slow, so we're rendering at 5 frames a minute. So you can see the whole rendering the whole short took about 9 hours. We have kind of restarted or are rethinking how we're approaching this, and we have a new sort of stochastic accumulation system, which also gives you a lot of potential for crazy filmic depth of field and a few other things. And then the other nice thing is it's actually much more performant as well. The next piece of that was actually what we just called the render window. On your right is the game view, and then on the left is just our render view. I don't know if you can tell here, but the fur here isn't fully converged. It's actually kind of a really noisy, kind of a dithered sort of approach for the viewing. But we wanted to be able to give the artist sort of what does it look like in the final render. So here we just had basically a render button that you could hit, and it would do the converge and show you the final accumulation and convergence. So it really improved the render quality and sort of the iteration speed. So yeah, some final stats. So again, we didn't do any storyboards, straight into 3D to find the story. We used sort of all the bag of tricks that Unity provides. And the project's actually available on the website in its experimental form if you want to actually rip apart and see how we did this. So it's the original, actually the Maya files as well, the source assets. You can actually open them up, see how they were exported, how all of the workflow. There's extensive README and documentation and blog posts and so on that we put together to support it all. So the last thing I want to talk about is what does linear animation mean for working in Unity? We're obviously abusing Unity in ways that it wasn't originally meant for. The way I think about a Unity project is it's kind of these 3 pieces. You have your code, which is your normal packages and custom tools and workflows. You've got your content, your models, animations, textures, and so on. And then you have the assembly, which is kind of bringing all these things together. So that's scenes, your timelines, and all these other things. So pre-2018, this is kind of what it looked like. You had your editor, you had your project, and you had your runtime. And everything was smushed into the project. So everything's kind of monolithic. Now, 2018 introduced Package Manager, which is really interesting because it allowed us to start modularizing the editor, modularizing the runtime. But the project is still kind of monolithic. We're still just stuffing everything into there. Now, in the world of 2019, we now have the ability to do things like scoped registries and custom Git packages. This is actually where I see things going. In fact, this is how we structure all of our projects. So we have obviously the official Unity packages, sort of coming from Package Manager, and now in 19.3, even the asset store. But for your own internal code and own internal packages, you can actually have a scoped registry. You can set up your own internal package system to deploy your own code to, or just point it at a GitHub repo or something. This is where things get really interesting for linear animation when you're trying to scale from a 2-minute project that's 12 gigs to, I want to do 22 22s or a feature film or something. You actually need to structure your stuff in kind of this sort of a model, where if you look at the traditional workflow where you have a look dev, you're working on the initial asset review, all of the surfacing, all of the things you need to do to get an asset ready. And then on the other side, you have the assembly. So you're putting everything together. You're using the assets that you've created, that you've done look dev on. The in-between is basically packages. So you can have sets as a package. You could have a character as a package. And then you're publishing those packages into your own internal package system. The beauty is they're semvered. They've got a versioning. You can actually track that in Shotgun. You can publish a version and actually know when you're assembling it, I'm pulling the proper approved version of a package into, or an asset into the project. And when you start looking at episodic series or TV or a feature film, you have potentially multiple Unity projects. The Unity project is where you're assembling all of these things together. But your common code is coming from packages, and all of your assets are coming from packages. And this is how you scale from a single Unity project to being able to do whatever 3,000 shots for a feature film, is being able to actually manage these kind of assemblies in a bit more of a modular way. It's a very different way of thinking about things, but it actually allows you to scale your production in an efficient way. An artist is working on scene 25, they can open scene 25 and only pull in the assets that they need. They don't need to load the entire 3 terabytes of assets that you might have for your feature film. So some advantages and disadvantages. So the advantages is you can actually explicitly version your code and assets. You can have some sort of a centralized management. Access control, scoped registries allow you to actually have permissions. So by default, packages are read-only. So artists can ingest them but not modify them. You can actually coordinate across multiple projects for a TV series. You can actually integrate that kind of the semver sort of mentality of packages into things like shotgun versioning or F-Track. And then obviously you should have all of your tools and code and everything in packages. Sherman has 0 lines of code in the actual project. Everything is in packages. Actually, most Unity projects I'm working on these days doesn't have any code in the project, and are kind of moving rapidly to the point of having no assets in the project. It has scenes and timelines, and that's it. And, well, HDRP configs and stuff like that. But the actual assets and code are now coming from this modular package system. The disadvantages are there's no real documentation on how to set this up. We're kind of making it up as I go. But this is the thing that we're working internally to figure out, is there ways that we can build tooling around this? Working with groups like Shotgun and F-Track, is there a way that we can actually build these publishing systems to sort of work this way? Obviously, the new asset pipeline that you guys saw in sort of the keynote and some of the other talks solves this idea of we still have to import the package. So if you have a whole bunch of content in a package, that first time you open it, it's going to be painful today. In the future, the on-demand nature of the new asset pipeline will actually solve that problem for us. And obviously the cache server and the new accelerator system will help with that. Setting up your own on-prems or a scoped registry, it's actually not that difficult. It's just the documentation isn't super complete. There's actually some really good articles out there. But if you look at solutions like MyGet, it's a third-party hosted package registry system. Or GitHub actually just launched their package registry I think it's in beta right now. Those are some really interesting opportunities where you can actually go from a Git repository, a couple clicks, to now it's a published package that has versioning. And as I mentioned, there's no real tooling around this yet. If you want to create a package from an asset, it's actually not that difficult, but there's just no tooling around it today. So, future discussions. So, things like addressables are really interesting when you get to this world. That idea of almost all assets in a project are static. So why aren't they coming from something like an addressable system, where you publish assets to this pre-packed, ready-to-go format, and then you're just ingesting them? You can actually load addressables at edit time. So you could actually assemble your scenes dynamically from a separate content service or something. Again, there's no real workflows around that. These are sort of areas of experimentation that I'm looking at. But I think it's really interesting. And something like an addressables architecture could look like this, where you've got your look dev, where you're working on your source assets, you hit publish, you publish your addressable, and then the assembly guys are pulling it in on the other side and just working with the published asset. So they don't ever have to see the live asset. They're just getting sort of the final ready-to-go version. So for more info, we've got, again, there's a 2-part blog. It's really long. The blog people didn't like me, so they split it into 2. There's the Film Solutions page, where we've actually got things like these 3 videos here are dedicated to sort of how we worked with Sherman and how we iterated on it. But it's a wealth of information on how we set up the project, what does the folder structure look like. And then if you're a real glutton for punishment, you can download the project and check it out yourself. Check out how we're actually organizing things in packages. We have multiple projects. There's just a lightweight starter project and the full one that are all referencing a similar or the actual same packages folder. So how can you structure things to scale your project? And then obviously there's more demos and some of the amazing Made with Unity content that's been created. So that's it.